Grade 8s, happy Monday. I hope you guys had an amazing weekend, got to do something fun or just enjoyable. This week we are taking a little bit of a turn because now that we're into our last month of the school year, I really want to focus on getting you guys ready for things that you're going to be seeing in high school, talking about little things that we have covered this year that are going to be relevant in high school and some next steps that are going to be taken. So that's what we're going to start kind of doing. So a lot of these units are going to be shorter. They may only be a day or two on each thing. But this is just so I know that when you guys are going into grade 9 next year that you're just going to be a little bit more prepared. So we're going to start off with our review, and then we're actually going to go into scatter plots. And we're going to do scatter plots for a couple days, depending on how that works out with something I was planning on doing with you guys. So for now, let's start off with our review. So we were talking about taking decimal numbers and timing them by the power of 10 as a way to take larger numbers and break them down into scientific notation or to expand them. So right now I have 7.38 times 10 to the power of 4. Easiest way for me to solve this problem, or for me to show the full form or the regular form of this number, is to take 7.38 times and then 10 to the power of 4, we know is 10,000 because it's 1 with 4 zeros behind it. And you just multiply them together. So what ends up happening is you end up with 73,800. That's what happens. Or you move the decimal place over 4 spots because we had 4 as our exponent. So 1, 2, 3, 4. And we end up with 73,800. And that's our final number. Our next number is taking this form and putting it into scientific notation. To do that, the easiest way I find is usually just taking this decimal that's at the end of the number and shoving it over so you end up with a single digit and decimals after it. You can technically do 58 points something. Usually though, you'd want to have it down to your first digit just being the ones, or just being a ones digit, instead of going into the tens or hundreds, because it's not fully proper. However, it still can be done. It's just normally done so it's only a single digit and decimals after it. So in this case, we're going to do it to a single digit. So I'm taking this decimal space and moving it over. I'm moving over 1, 2, 3, 4, 5, 6 spaces. So I end up with 5.86. I can just eliminate those zeros at the end for now. And times 10, and we have to figure out what that power number is, or what the exponent is. Easiest way is we move that decimal place over 6 spaces. That means it's going to be 10 to the power of 6. Because if I expanded this times 1 million, it would be 5,860,000. All right, so that is our review. Today we're talking about scatter plots. So today we're just talking about trends that you can see in scatter plots where the data is already done for you. You're talking about the relationship in the numbers and why and what kind of conclusions you can draw from how the data is presented on a scatter plot. The reason I want to spend some time on scatter plots especially is because right now in grade 8 we usually just do scatter plots that just have a regular x and y axis. And we talk about the data and things like that. In grade 9, starting grade 9, you start seeing scatter plots on a coordinate grid. And the data can be all over the place, and you're talking about the rules when it comes to it being on a coordinate grid. Now, the good thing is, for the most part, when you're talking about the relationship of the data and how it's presented, it's actually very similar to how it's presented on our graph right here. And the same kind of sentences you can use to describe the data can be used on a coordinate grid. The big difference is the actual math and the actual plotting of the data. So let's get into our example. So let's say this is a scatter plot of a random class's marks and a report for an assignment. And the bottom is the time that was spent on the assignment in hours, so how much time each individual student spent on it. And then this right here is the score. So the scores are percentages, let's say, up to 100. So how I can present this data is, so if I have our random scatter plot and I have random points of data, so we're looking at this. Let's say this is the data that we are given, that we can see that majority of students spend more time on the assignment than less, and that the more time that they spent, more often than not, the better mark that they got. What we need to do here is determine the line of best fit. The line of best fit is basically, you see how these dots are all kind of going in a direction? The line of best fit is basically a line that more or less follows that direction. It does not have to actually cross any of these individual points. It can just run freely through it. So it could just run right through here. The line of best fit you use to there are computer programs out there that will actually do the line of best fit for you, that can figure them out way more precisely than you can by just looking at a graph. However, you can also just draw one yourself. If you're looking at just basically conclusions you can draw from the data. So in this case, I could just draw it myself. Reason being is because I'm trying to figure out what kind of correlation that there is between this data. So I'm determining whether this is a positive correlation or a negative correlation, and if it's positive or negative, is it high positive or low positive, high negative, low negative? What this means is, positive means the data is going up. It is going from left to right. It's going kind of in a, if I'm talking about a compass directions, it's going in a northeast direction. That means it's positive. Negative means it's usually going this way. Now, what this means is from this graph right here, I can determine that there is a positive correlation because this line is going in this direction. There is a positive correlation, as in more time spent, higher score. More and higher, those are your kind of key words there. Now, I have to determine whether it's a high or a low correlation. High means it has a very steep line. Low means it's not so steep. It's lower. Usually, if it's somewhere right in between, you would just say either a regular positive correlation, or if it makes you choose an option, usually you put it as higher because you can see that there is a lot of higher scores here that are in that time zone of more time spent on them. So in this case, this particular set of data is a high positive correlation. That means, on average, that the more time the students spent on that assignment, the higher the score they got. Now, of course, there's always going to be a couple outliers. There's always, maybe there are some students who didn't spend too much time, but they still got some pretty good marks. And there are some students who spent a lot of time but didn't get as good of marks. There's always going to be outliers in sets of data, especially when you're talking about scatter plots. What you're talking about is the bulk, and what's basically majority rules. So that is one example of a high positive correlation, and that's how we can determine. Now we're going to talk about negative. So I'm going to erase this, and I'm going to plot out a graph that would have a negative correlation. Okay, so here's my little jump cut. I finally figured out how to do those. Here is another graph. This time it is the usage of the heater in terms of the temperature outside. So I'm talking about the time that the heater is being used throughout the day. So obviously higher temperature, less time, because like if it's 30 degrees outside, heater's probably not even going to go on all day. It's probably just going to be the air conditioning. So that means it's very low time, but very high temperature. As you can see, this is going in the opposite direction of our last graph. So our last graph, we were going in this kind of direction. This time you see it's kind of going in this direction. It's going in a downward slope. This means that it is a negative correlation. So positive is this way, negative is this way. So I have a negative correlation. Correlation describes the relationship between the two different points of data. So in this case, temperature and time. The last one was scores and time. Often time is used more often than not for scatter plots, just because of just the way it ends up being graphed out. But there's obviously other exceptions, such as like height versus shoe size. So in this case, we're talking about the correlation between the temperature and the time. Higher the temperature, the lower the time that the heater is being used. Now, what if this is about air conditioning? Well, higher temperature, the more the air conditioning is used. That could be a positive correlation. But in this case, we're talking about a negative. So as you can see that with my temperature going up, I'm using the heater even less. Now I need to figure out if this is a high or a low correlation. So high means that it would have a very steep line, kind of like this. Low would be like this. It's a gradual decrease. In this case, you can see that it is a very gradual decrease. It's not a very sharp turn that's like from 30 down to 1.5 with a high temperature. It's very much gradual until it gets up to 3 hours. So in this case, it would be kind of a lower negative correlation. So high just means it's a very steep line. Low means it's not so steep. In this case, it's low because it's a very gradual decrease and there's no sharp lines that are decreasing. So that is what we're going to be talking about today. So you're going to actually have a set of multiple choice questions where it is going to give you a set of data. You need to figure out where the line of best fit kind of would play. And if that means that the data has a low or high correlation, is it negative, is it positive? So it's very easy because it's just multiple choice. And then the next part is it gives you scenarios. So for example, the air conditioning usage in a family's household and what you can determine from that data. So like, for example, the heater is being used less the higher the temperature is. So I can determine that the higher the temperature, the less I'm using the heater. Once I hit the 15-degree mark, when it's only 15 degrees out, the heater is only being used an average of 1.5 hours or something like that. So that's essentially what you're going to be doing, is basically interpreting data that is given to you. And on Wednesday, we should actually be graphing some scatter plots. And I'm still trying to figure out the details of how we're going to do it, because some of you I know will be fine just doing it on pencil and paper, but I also want to give you guys the opportunity to do it electronically on Google Docs if you so choose to do so. So on Wednesday, I'll give you more details about how that's going to work, but for now, it's going to be regular questions where some of them are going to be multiple choice, and some of them might just be some short answer like, oh, therefore this is a low negative correlation, something like that. All right, so that's all I have for you guys today. It should be pretty easy and more or less kind of review. And if you have any questions, be sure to email me before, and then I'll see you guys on Wednesday.